Alright guys, welcome to EE Science 2. This is Pedro Lopez. I'm going to go over regenerative braking. So one of the biggest concepts we had this semester was induced current. So induced current is the basis of how regenerative braking systems work. So we know that from a galvanometer, which we can see in the bottom right of the slide, that as you rotate a coil inside that magnetic field, a change in flux is going to be happening. As you increase the change in flux, you'll have as more and more flux is going through the coil, we're gonna have a bigger current induced inside that, and that's due to the magnetic fields lining up a certain direction. Obviously, in this picture right here, you can see that since there is minimal magnetic flux going through that coil, we're going to be at that 0 point, which we can see from that graph. And if you keep rotating it and in the opposite direction, the magnetic flux is going to be going in the opposite direction through that coil, and the current's actually going to be going to the left side or the right side. It depends which way it goes, but we need to know that when it's rotating, it's going to be generating an AC current because it's going to be going back and forth from the left to the right, and obviously the 0 point is in the middle. So in electric vehicles, we can take that since they already have a motor involved. We can turn that motor inside the electric vehicle into the AC generator. AC generator is just it's just backwards of a regular motor. Instead of a battery supplying power to a motor and powering a vehicle, we'll have the vehicle supplying kinetic energy to the motor, which is powering the battery. And we can see that due to the galvanometer and the AC generator right there. The big problem is that when you do have current going in two different directions back and forth all the time, you're going to have a net output current of 0. But if we pass that through a commutator, which is something I looked up to figure out for this class, we can get a consistent current going in one direction and charge a battery. So like I said, we implemented cars today. One of the biggest things is we take the kinetic energy of the car is moving, we're going to apply this regenerative braking system, which helps slow the car down so we don't have to use brakes as much, and it's going to as well charge the battery. As we can see from the bottom picture, we'll have the kinetic energy going through the transmission, the motor controllers helping get that current going in one direction so we can charge a battery consistently and at a constant rate. But one of the things is regenerative braking is not 100% effective or 100% efficient. Nowadays, I looked it up, it's about 70% efficient on newer models now. So we can get 70% of the energy back from the kinetic energy spent on stopping the vehicle, which is really good. One of the other implementations is that as soon as you let go of the gas pedal, you don't have to press the brake pedal, and that's due since the regenerative braking system automatically slows down the car. That way, you can save a little bit on your brake pedal, on your brake calipers as well. One of the disadvantages is that regenerative braking is not nearly as efficient as traditional brakes at stopping the vehicle. But that's not the biggest deal in the world unless it's an emergency situation. Obviously, when it's an emergency situation, you press the brake pedal and you depress it all the way down. Regenerative braking is going to be applied and traditional braking is going to be applied. That's one of the downsides to it is that when you have regenerative braking enabled in the car, if you press the brake pedal a little bit, it'll start using the regenerative braking instead of the traditional brakes, and you're gonna have to kind of get to that point where you feel the difference between regenerative braking and the conventional braking being applied. Most newer cars have systems where you can set either lower standard regenerative braking, as you see in the bottom right, and this can help with stop and go traffic. Since in stop and go traffic, you more or less want to keep coasting throughout the traffic and not stop so much when you let go of the gas pedal. That way you can get more use out of your car and energy versus wasting it, stopping and doing all the time. All right, and that is it. I appreciate you guys' time this semester. Thank you guys for the help, and I hope you enjoy your summer. I hope to see you guys in the future. Adios.